my eraser and scratch paper. Scratched paper.
Okay, let's do this.
Right.
And we want to get this in a high yield. Oh, okay, maybe I should just say, let's just go by way of the triple bond. Because you can't just skip the triple bond, do the triple bond to get this product. But. So what's your first step?
So you want to go by triple bond to get to...
Get to that, yeah.
Okay. Well, first we have to make the... Let's see, the double bond has to be there then. So from there...
So yeah, what do you think? You kind of said something
Yeah.
backwards. Yeah, if we're thinking backwards, you know, double bond has to be here.
Uh-huh.
And is it going to be cis or trans? Or does it matter?
It's going to be... It's going to be trans because that one right there is trans.
Yep. Perfect. So if we know we're going by way of a triple bond, how can we get from here? Can we form this from a triple bond? So this
Yeah, if we did...
we're adding proxy acid.
Right. If we did the hydrogenation with the Lindner palladium.
That gives you cis. Lindner palladium gives you cis. Trans is when you add sodium with ammonia, NaNH3.
Could I see the actual, I guess, mechanism on like what grabs what? Then?
For this step?
Yeah.
Yeah, let me do that. So let's say we have a double bond here.
Mm-hmm.
Sodium is going to be like a single bond. And so what happens is it dumps one electron. And so then you're going to end up getting, sorry, we have a triple bond here. So you get this double bond with this negatively charged, because two electrons come together. Then you have a radical here. So you have this NH3 over here. And this negative charge grabs the hydrogen. Okay, and then you have this radical, you still have your radical here. And then sodium dumps another electron. Is that right? Yeah, sodium dumps another electron, so you have this negative charge, you still have your double bond. Then this grabs another hydrogen from our NH3. And for some reason it makes trans every time.
Okay, so NaNH3, so you have NaNH.
So note, I didn't write NH2 on this.
Yeah.
That's somewhat, people get confused because you just get used to writing NaNH2, NH3.
So you know it's not, you didn't write it, it's actually...
No, there is no NH2
there is
here
no NH2 there.
on this
Okay.
one.
Okay, so sodium jumps one of its electrons, or I guess combines this electron with a triple bond electron.
Which forms our negative charge and then a free radical.
Okay, and then the negative, or The negative on the NHO2 or the negative on the carbon
Negative on the carbon.
grabs a positive from the NH2 or
Grabs this hydrogen from NH3.
grabs a hydrogen. Okay, I see now. I see. Grabs a hydrogen, puts it on there. And
Then another sodium dumps off.
oh, okay.
Another.
Gotcha.
And then that forms a negative charge, and then that grabs another hydrogen from H2. So I guess technically, I never wrote this, you need 2 moles of NaNH3 to make this trans.
Okay. And that's why, because she said in class that NaNH3, that Na is more of the metal, it's in the metal form, it's more of a catalyst. And
That's why it said this radical, it can just dump an electron.
Okay, that makes more sense now.
So we're just doing that synthesis now. Good deal. Good stuff. Starting material ending product. And we want this to be trans, so we're going to go by way of a triple bond. You want it to be trans. I'll explain why in a sec, but, well, I guess it doesn't. I don't know if it really increases our yield. But I'm just specifying we want to go by way of triple bond so we can think that through.
Okay, gotcha.
So we have this as trans, so we know it's going to come from a trans double bond.
Mm.
And so then we're going to say, how can we make a trans double bond? Can we make it from a triple bond? Yes, we can by adding NaNH3.
Now, if you wanted cis from a triple bond, would you use the Litter or
Lindlar platinum.
Lindlar?
Mm-hmm. H2 with Lindlar platinum.